Good morning, dear students. I hope you are all safe by staying at home. And last week we had seen the preparation of ethanol in the laboratory, in the industry, and then its chemical properties, physical properties we had seen. Today we are going to see the uses of ethanol. It is an antiseptic. It is used as an antiseptic for wound as well as medical wipes. Medical wipes like a knife, thermometer. Okay, so it is used as an antiseptic for wiping the wound as well as medical wipes, and antifreeze in automobile radiators. And then in hand sanitizer also it is used, and then it is used as a solvent for drugs, perfumes, paints, etc. And then it is used for the manufacture of methylated spirit. Methylated spirit means 90% of ethanol and 5% of methanol. The mixture of 90% of ethanol with 5% of methanol is called methylated spirit. So in the manufacture of methylated spirit also ethanol is used, and then in the manufacture of rectified spirit means 95.5% ethanol and 4.5% of water. And then it is used as in the manufacture of power alcohol. Power alcohol means ethanol with petrol, and then it is used in the manufacture of denatured spirit. Denatured spirit means ethanol with pyridine, and then it is used as food extract. For example, we are adding vanilla flavor in ice cream. If we want to get good smell, good flavor from the ethanol, from the vanilla beans should be soaked in ethanol for getting to enhance the flavor. So these are the uses of ethanol. And next we are going to see ethanoic acid. Ethanoic acid or acetic acid. It is otherwise called acetic acid also. So we are going to see ethanoic acid, how it is prepared in large scale, and then what are its physical property and what are its chemical property and its uses. We are going to see. First, how it is prepared in large scale. Ethanoic acid is prepared from the ethanol. Ethanol, when it is oxidized, the presence of alkaline potassium permanganate or acidified potassium dichromate. So it is oxidation process. When ethanol is oxidized, the presence of alkaline potassium permanganate or acidified potassium dichromate, ethanoic acid or acetic acid is formed. So this is preparation of ethanoic acid in large scale. And next we are going to see physical property. It is colorless, unpleasant odor, and it is soluble in water in all proportion, and it is used when it is cool. When we are freezing that, it will be forming glaciers. Like glaciers it will be forming, that is called glacial acetic acid. So these are the physical property, and its boiling point is little bit higher than its boiling point is higher than its alcohol and then alkane. These are the physical properties of ethanoic acid. And then since sour taste is the characteristic properties of acid, so ethanoic acid is sour in taste. And then next we are going to see chemical properties. First, how it is reacting with metal. How ethanoic acid is reacting with metal. The metal like zinc and sodium, when it is reacts with ethanoic acid, it forms respective ethanoate. For example, ethanoic acid, when it reacts with zinc, it forms zinc ethanoate with the liberation of hydrogen gas. And ethanoic acid, when it is treated with sodium, it forms sodium ethanoate with the liberation of hydrogen gas. So this is the first property. Zinc is bivalent, that means its valency is 2, but sodium is monovalent, so it consumes 2 molecules of ethanoic acid. And then reaction with the sodium bicarbonate and sodium carbonate. When ethanoic acid is treated with sodium bicarbonate, it forms sodium ethanoate with the liberation of carbon dioxide with the formation of water. And then when it is reacting with the sodium carbonate, it forms the same product, sodium ethanoate, and then with the liberation of carbon dioxide with the formation of water. And then reaction with the base. When ethanoic acid is reacting with the base like sodium hydroxide, it forms sodium ethanoate or sodium acetate with the formation of a water. This is neutralization reaction. This is weak acid. Acetic acid is weak acid. When it reacts with the base, it forms salt and water. So this is a neutralization reaction. And then decarboxylation. Decarboxylation means removal of carbon dioxide. When sodium salt of ethanoic acid, this is the sodium salt of ethanoic acid. The name of the compound is sodium methanate. When it is treated with the soda lime. Soda lime means 3% of sodium hydroxide with 1 part of a calcium oxide. That is, the combination is called soda lime. When it is treated with the soda lime, methane gas is liberated with the formation of sodium carbonate. So these are the chemical properties of ethanoic acid. And what are its uses? It is used as additive, and it is used in the manufacture of plastic, paints, and then it is used as lab reagent, and then coagulation of rubber. Coagulation of rubber means making the rubber as a solid. When we are getting the rubber from a rubber tree, it will be in the liquid form, that is called a latex. So the latex cannot be that cannot be used for manufacturing the other things that is made up of rubber. So the latex should be coagulated. When we are adding ethanoic acid with latex, it will be forming solid form, that is called that process is called coagulation of a rubber. Now we are going to see about soaps and detergents. Soaps and detergents also the organic compounds, and we know that soaps, how they are used in our life. That is used as a cleaning agent for clothes as well as our body. While we are using the soap for cleaning the dirt, one chemical molecule, surfactant, will be there in a soap that will break the surface tension of water. So soaps are used for cleaning, removing the dirt and stain from the clothes. And what is soap means? Soap is composed of one or more salts of a fatty acid. It is composed of, soap is composed of one or more salts of a fatty acid, and detergent is a chemical compound or combination of chemical compound. And then now we are going to see soaps. Soap is nothing but it is composed of one or more salts of long chains of carboxylic acid, long chain of carboxylic acid, and the carboxylic acid is nothing but a fatty acid. So it is a combination of one or more salts of long chain of carboxylic acid, that is a fatty acid. Otherwise we can say that saponification. The combination is the process of combination of this is called saponification. Saponification of one or more salts of long chain of carboxylic acid or fatty acid, that is called soap. And we can divide the soap. Soap contains two content. One is alkali and second one is a fatty acid. It is a combination of alkali and fatty acid. Alkali, we are going to use two kinds of alkali. One is sodium hydroxide and another one is potassium hydroxide. When sodium hydroxide is mixed with fatty acid, it forms a hard soap that will be used for a washing purpose. That is washing soap. This is washing soap. So when sodium hydroxide, saponification of sodium hydroxide with carboxylic acid forms a hard soap, that is used for a washing purpose. And potassium hydroxide, saponification of potassium hydroxide. So saponification of potassium hydroxide with carboxylic acid forms soft soap, that is used for cleaning the body. So these are the two kinds of a soap. And now we are going to see how the soap is prepared in small scale as well as a large scale. The oil which is used for the preparation of soap is taken in a iron tank. Is taken in a big iron tank. The oil which is used for the preparation of a soap is taken in a big iron tank, and 10% alkaline solution is added with that. After adding that, steam is passed. Steam is passed over that solution. Because of that, the oil is getting hydrolyzed. So that is called saponification. That process is called saponification. Then the common salt is added. After the process of saponification, common salt is added with that. When we are adding salt, it forms a precipitate. The soap will be formed as a precipitate that will be precipitated at the bottom of the tank. If you are leaving the mixture for several days, the soap the soap precipitate rises over the top portion of the iron tank as a curdy mass. That will rises over the solution and it forms curdy mass. That curdy mass is skimmed off and cooled down to get the soap. So this is the preparation of a soap. And then what are the effects of soap? Effects is the soap is not good for removing the dirt from the clothes in hot water. It will not be effective in hot water. Why it is not effective in hot water means hot water contains the ions of calcium, salts of calcium and magnesium. These two salts will be dissolved in hot water. So when we are using the soap with the hot water, the soap will be reacting with the calcium and magnesium ion. It forms a scum. The scum is the sticky precipitate that will be sticking to the clothes and it will spoil the quality of cloth. That's why we should not use soap with hot water, because it forms a sticky layer over the fabric that will spoil the quality of the fabric. So soap is not effective with the hot water. And then next we are going to see detergents. Unlike soap, detergents are the best use of removing the dirt and stain from the clothes even when we use hot water, because it will not form scum. Detergents will not form scum with the hot water. It will be it will be removing the calcium and magnesium ions effectively. It will not form scum. It will not form the sticky layer over the fabric. So the fabric will be maintained as before. And then how it is prepared, how the detergents are prepared. The sulfuric acid is treated with a hydrocarbon taken from the petroleum product. This is the petroleum product. So the hydrocarbon taken from the obtained from the petroleum product, with that we are going to add sulfuric acid. So when we are adding these two, already we had seen in soap, the saponification process takes place. So we will be getting the soap like structure. When we are adding alkali with the soap like structure, it will form detergent. Why we have to add alkali means alkali will be acting as a surfactant. Surfactant means already I told that will reduce the surface tension of water. So dirt and stain will be removed from the cloth easily. And then what are the other things? What are the other things are added with the detergents to enhance the quality of detergents? Sodium silicate is added to prevent corrosion, because when we are using the detergent for long time, this cloth fabric will be corroded. So when we are adding sodium silicate with the detergent, that will prevent the corrosion. And then fluorescent will be added to give glow to the cloth. And then oxygen bleaches are used to remove the stain, grease stain and other oil stain and all can be removed when we add oxygen bleaches. And then sodium sulfate is added to prevent the caking of soap. Caking of soap means the soap will turn into hard like a stone. So to prevent the stone like structure, that means caking, we will be adding sodium sulfate with the detergent. And then enzymes are used to remove biostains. Biostains means vegetable stain and blood stain. To remove the biostain, we will be using enzymes. Active enzymes are added, and chemicals, some of the chemicals will be added with the detergent to give pleasant odor. Now we are going to see cleansing action of soap. Cleansing action of detergents or soap. It contains two parts. Soap contains two parts. One is polar end. One end is polar end, that is acting as a head. And that is end with a carboxylate group. So it contains head and tail. The molecule contains a head and a tail, short head and long tail. The short head contains carboxylate end, and then it is called polar end. And another one is the tail part is a non-polar end, which is which contains hydrocarbon, in next the polar end is otherwise called, the polar end is hydrophilic in nature. Hydrophilic in nature means water loving nature. Water loving nature means easily it will react with water. So the polar end is hydrophilic in nature, whereas non-polar end is hydrophobic in nature. Hydrophobic in nature means water hating. This is water hating, this is a water loving nature. So when the polar end will be attracted towards the water molecule. The polar end will be attracted towards the water molecule, whereas non-polar end will be attracted towards dirt. So when it is when the non-polar end surrounds the dirt, the head part, that means the polar end, makes the entire thing soluble in water. So it will dissolve all the things. The dirt molecule, when the non-polar end surrounds the dirt, the polar end makes the entire molecule to dissolve in water. So the dirt will be removed off from the clothes, and when the molecules join together, it will be forming as cluster. That cluster of molecule is called micellar. And then next we are going to see advantages. What are the advantages of detergents over soap? It is used in, detergents can be used in hot water, saline water, acidic water. It can be used in all kinds of water, and it will not form, it does not form scum. So the fabric will be prevented from corrosion and sticky appearance, and then it dissolves freely in water, and it removes the dirt particles easily from the clothes, and then it is effective in woolen garments. So whereas soap cannot be used for removing the dirt from the woolen garments, detergents are effective. Soap cannot be used for removing the dirt from the woolen garments, and it is biodegradable, and then it is effective and safe for synthetic. These are the advantages of detergents over soap. And then next we are going to see types of detergents. There are two kinds of detergents, biodegradable detergent and non-biodegradable detergent. Biodegradable detergents have long chain of linear chain of a hydrocarbon. It contains linear chain of a hydrocarbon, and a non-biodegradable detergents contains branched chain of a hydrocarbon. So this is the difference between biodegradable and non-biodegradable. And what are the disadvantages of detergents? The non-biodegradable detergents, when it reacts with water, it pollutes the water, and then it is costlier than soap. That's all. The lesson got over. In this class, we had seen how ethanoic acid is prepared in large scale, and what are the chemical properties, physical properties, uses, and what is the definition of a soap, detergent, and how soap is prepared in large scale as well as small scale, and what are the types of soaps, and how the detergent is prepared in industry, and what are the types of detergents, and how the soap is getting the cleansing action. What are the parts involved in cleansing action of soap? These are the things we had seen in this class. In our book, the difference between detergent and soap is given as tabular column. I think you can understand. By reading that, you can understand. That's all. The lesson got over. Stay home, be safe.